Hello and welcome to this quick intro to Unity scripting. In this video I will show you how to make a script, how to edit it, and the basic way that Unity and the scripts interact with each other. This is not a full programming introduction, that would take way too long, but just a small overview of the basics. So don't worry if you don't understand all of the code that I'm going to write here, that we will talk about later more in detail, but just have a look at how the scripts are working, how you set parameters, and how Unity calls different kinds of functions. So yeah, let's make a little game here where we have a bird and a tree, and then the game should simply restart if the bird runs into the tree. Let me zoom out a bit so we can see in the scene view the entire area that the camera is seeing. Also, just put the tree over here and the bird over here. Alright, this looks good to me, so let's start scripting. Let's first start by making the bird move. So for that we need a new bird script, and you can simply right click inside the project, say create, and C# script. We will call this bird movement. And now we have a first script. We can select the bird object and simply drag the script on it, and now it is applied. So we have the bird movement script on the bird object. Of course, it doesn't do anything yet, it is completely empty. So in order to edit it, you either right click here in the inspector and say edit script, or you can also double click inside the project window on the file. If you do that, it should open Visual Studio or your selected code editor. Okay, it's my firewall. Yes, you are allowed to access. And if it doesn't open like this, you have to select your preferred script editor manually. For this, you go to Unity, go to Edit, and Preferences, go to External Tools, and then select the external script editor that you want to use. For me, that would be the Visual Studio Community Edition here. That is a great tool to work with Unity because it has complete Unity tools and library integration and syntax completion. So let's have a look here at the script. You can see it is a C# class that extends from MonoBehavior, which is the base class of all kinds of C# scripts inside Unity. We have a bunch of imports, for example, the Unity engine, so we have all of the Unity functionality available to us, and two functions which are here by default, start and update. If I want to learn more about these, I can hover over the three little dots here, and it will, for example, tell me, oh, look, start is called just before any update method is called the first time. Okay, so start would be our setup method, and then we have update, and update is called every frame if this MonoBehavior is enabled. So update is the method that we want to use to manipulate our position in real time on the screen. And these functions are called by Unity if the MonoBehavior or the C# script is on an object, so we don't have to worry about calling them ourselves. You can also see that we don't have a constructor, so if you know some C# programming, you know that a class should have a constructor. We don't have one here because the instantiating of this script is handled by Unity itself. If we look at the Unity engine, we can look on the bird, and the script is attached here. And this attached script is basically our created instance of this class. So we don't have to worry about instancing or creating an instance of bird movement ourselves. That's also all handled by Unity. So it's basically like C# programming with a little bit of Unity magic around it. So let's start by making the bird move. And to move an object, we need to modify the position of the transform component here. We can access the transform component by simply writing lowercase transform, which is a field that comes from MonoBehavior here. So we have access to that, and it holds a reference to the transform component of the game object. So we of course have the field position here. And then we want to say, okay, this position is a vector 3, so we can plus equal another new vector 3 on top of that. Let's just say something like a little bit to the right, so a bit of x value here, and no movement on y or z. Okay, let's have a look at what happens if I click play now. And there we go, our bird moves to the right. So Unity automatically compiled the new version of our script and updated its instance on the bird, so we can immediately see how our new script works. Let's have a look again at what we just wrote, and we can see that we used update to change the position a little bit every frame. So one of the most important concepts when working with Unity is to keep in mind that it is a real-time application that runs at a certain frame rate. So we produce a set amount of frames every second, and every frame update is being called. So in this case, we would change the position by 0.01 or add 0.01 to the x value of the position every single frame. So if we would have more frames, if our computer would run faster and we have 200 frames per second, we would move 200 times 0.01, which would be 2 units to the right every second. If we have a slower computer that would run only at 50 frames per second, we would only move at 0.5 units to the right every second, so a lot smaller, a lot slower, which would be a problem. So any kind of movement that you program always has to be accounting for different kinds of frame rates. And I am throwing this into the very first programming tutorial already because it's just really such an important concept of working with Unity. So let's go ahead and account for different kinds of frame rates, which is actually quite simple. Instead of having a set value here, we would define how many units do we want to use or do we want to move per second, and that we do by defining a field that we call speed. We can set an initial value of 2 here, so 2 units per second, and then instead of putting 0.01 here, we would say speed multiplied by time.delta time. Time.delta time is essentially the time that one frame takes to execute. So in other words, let's say we have a frame rate of 200 FPS. Delta time would be 1 divided by 200 or 0.005. So at 200 frames per second, one frame takes 0.005 seconds, and update gets called 200 times every second. Now our speed is 2, so if we multiply delta time by speed, we would get 0.005 times 2, which is equal to 0.01, and this is the amount that we move every frame in the case that we have 200 FPS. And if we have 200 FPS, update is called 200 times every second. So we would move 200 times 0.01, which is 2, which is our speed. So the speed that we want to move every second. Okay, now then let's have a look at our Unity editor again. If I press play, you can see that we move at 2 units per second now. And if I go to the bird object and I look at bird movement now, you can see, oh, our speed variable actually popped up in the inspector. and I can change the value that it has. And that is because I declared the field speed as being public, and any kind of public field is exposed in the inspector. If I would make a private field, just call this test. Now this is not showing up. So private fields don't get exposed, public fields do. This is really quite handy because now if I want to test different kinds of speeds, I can simply go ahead and manipulate this and try out, oh, maybe this I like better. And I don't have to go into the script editor and manipulate the number I assign here every time and then wait to recompile and then try out. So the workflow is quite a lot faster. So the value that we assign here simply is the initial value of the variable when we first assign the script to an object. And then from there on, Unity will keep track of the number that we assign in the inspector, and that's the one that is being used. Also quite good to know is that you can manipulate these values in play mode. So let's make this a bit smaller, then I can show you. So now in play mode, I can actually manipulate speed. You can see that it directly updates. You can even make it move backwards. And then if I exit play mode, it resets to the value that it had before. So it's a great way to try out different kinds of values for your movement or adjust your gameplay without having to remember what the initial values were. Next, let's make sure that the bird can collide with the tree. For this, we first have to set up the collision detection between the two so we can detect an overlap. And for that, of course, both need to have a collider. For the bird, I am going to add a sphere collider. And then for the tree, because it has a sort of irregular shape, we could use something called a polygon collider. And you can see that the polygon collider automatically generates a collision shape that is sort of aligned with the sprite. But you should be careful when using polygon colliders, because if you use too many of them, especially if they are on physically active objects, so objects that move, they have a higher performance impact. That is usually not a problem if you have static or not moving objects with polygon colliders. But if you have like 100, 200, 1000 or so moving objects and they all have polygon colliders, your game might run quite slow. Good. Now we also need to have a rigid body, at least at one of the objects, so collision events happen. They don't happen just when two colliders touch. At least one of them needs to have a rigid body. So let's add that on the bird. The general convention is that you want to... Oh, that's actually quite good. We show that I can't add the rigid body 2D because I accidentally put a sphere collider on here, but I of course want to have a circle collider. The 2D version of the sphere collider. Now, back to the rigid body. The general convention is that you add the rigid body on the moving object. So let's add the rigid body 2D here. All right. But if I press play now, you can see that, of course, our bird falls off screen because it has a rigid body and rigid bodies have gravity. And the easiest solution to that is simply to set the gravity scale to 0. All right. Now we have collision, and if our bird goes and collides with the tree, there you can see it can't move through it. All right. Now that we have made sure that the bird and the tree can collide, means that collision events are fired. And that means that we can listen to those collision events and make something happen when a collision happens. Unity events are anything that is called inside a script from outside by Unity. For example, update would be a Unity event, start is a Unity event. Or the one that we want to do is on collision enter 2D. This is another function or an event that's being called by Unity should an object that has collision, or 2D collision in this case, collide with another 2D object. And as a parameter, we get a collision object that holds information about the collision event. What we want to do is, should the bird collide with the tree, simply restart our scene. And to restart the scene, so sort of generate a game over moment and reload, we first have to import scene management. Sorry, that is Unity engine.scene management. Which is the namespace that holds any kind of scene loading and management behavior. And now that we have that, we have access to the scene manager, which has a function called load scene. And since we simply want to load the scene that we actually already have, we say get active scene. And of this, we would like to have the name. Since the load scene function, you can see here in the pop-up, likes to have the name of the scene to load as a string. So we could simply look up, oh, what is our scene called? That would be sample scene, or since we want to load the currently active scene, we can use this here to get the name of the currently active scene. All right, well, let's test that out. Just gonna make the bird a little bit faster and hit play. And there we go. Now, once the bird hits the tree, we simply reload the scene and start anew. Now, let's say there is a problem with the function and it's not working the way that we want. In that case, the best tool is the debugger that Unity has, or that Visual Studio has to support Unity development. To use that, we can set a breakpoint here and then hit this attach to Unity button. And what's now going to happen is that Visual Studio is going to listen to the code execution, and if this line is ever executed, it will halt the whole program, stop execution, and jump into the debugger. So let's try that. If I hit play now and wait for the bird to collide with the tree, you can see, oh, everything stops, and I'm here now in this stepwise debugger. And now you can observe any kind of values that at this particular moment in time exist. For example, if we hover over name here, we can see that this would return sample scene, which is the correct kind of scene name that we want to throw into the load scene function. And I can step through my code. There's nothing to step through now. Of course, there's only one line, but if you have a very complex code, this is an excellent tool to help you out. And it works exactly like any kind of other debuggers that you might have encountered in your education or coding experience. And if I want to continue execution, I simply say, oh, continue, and now Unity will run again. And then, of course, stop again when we hit the tree. I use the debugger absolutely all the time, and it is the one most important tool for software development. And it helps you discover all kinds of bugs, and without it, it would simply be a lot more tedious and harder to develop for Unity. So to sum up, we learned how to create new scripts, how to attach them to game objects by dragging them on as components. We learned about Unity messages or events that are called inside the scripts by Unity. So that would, for example, be the start function, the update function, or the collision enter function. And of course, you can define your own functions or your own classes, just like regular C# programming. But you have all of these kind of hook points on Unity to communicate with your scripts. And we learned that any kind of public field that you declare in your class is being exposed in the inspector. And then finally, there was a quick programming introduction on moving and how to use delta time to account for the frame rate inside your game.